Hello everybody and welcome to CP1d Velocity Time Graphs. You know the deal by now, let's get on with it. So, the first thing that you'll notice when you see a velocity time graph here is that unlike distance time graphs, which go on two axes, a velocity time graph can go into the negative as well, because if you're travelling backwards, you have a negative velocity, because velocity is a vector, which is very good to know. Velocity is vector, speed is a scalar. Speed, if you're going backwards, that's still speed, positive, but if you're going backwards, that's a negative velocity. So, let's look at this. Velocity can go into the negative, and if we look through here, A shows a constant speed because it's flat, and it's a constant velocity. B, if we look here, B is slowing down to a stop at 0. C is waiting because it's staying still. Time is continuing, but velocity is not changing. D is travelling downwards, so it's negative velocity because it's going downwards or backwards, and a constant speed at a negative speed. Oh, sorry. D is speeding up to a negative speed, so accelerating to a negative speed, and E is the constant speed at that negative velocity. So, that's ultimately that, but the most important part of the whole topic is this, calculating the distance travelled from a graph. So as you can see, the velocity is on the y-axis and the time is on the x-axis, but the question is, how do you find the distance? How on earth do you get distance from this? You've got to be able to find it somehow, because they're not showing you, and a question might be, this is the velocity time graph, from point A to point B, what was the distance travelled? So, the distance travelled is the area, I believe, it's the area underline. Distance travelled on a velocity time graph is the area under the line. So, now we've got that, we can go through these three different examples. So, this first bit here, between 0 and 5 seconds, you'd simply take the y-axis and multiply it by the x-axis, like how you'd find the area of a rectangle, take two sides and multiply them by each other. So 5 seconds times 10 meters per second in velocity equals 50 meters. And if we reinsert that into our formula triangle, if I just draw another one quickly, just tiny one up in the corner, and we go with velocity time. So velocity would go here, so velocity is 10 and time is 5. 5, and you can see that 10 times 5, so if we're finding out the top, which is distance, it's 50. So that is just how to find out distance. The next example is very important because, as you can see, it's not touching the bottom and it's an angle, which is very interesting. So to find the distance travelled between 5 seconds and 10 seconds, you take this triangle bit and this rectangle bit and add them together. So if we go here, we can find 70. So when you're working out the area of a triangle, you take the base and the height and divide it by 2. So the base length is 5 and the height is I'm not sure about that. Yes, 30, because the difference between 10 and 40 is 30. So height of 30, width of 5. I'm sure it says here somewhere. And then of course you half it. So half, because it's a triangle, times 5 seconds times 30 meters per second is the height, equals 75 meters. So you just travel 75 meters in the triangle, and if you take here 5 and then 10, 50, and if you add them together, 50 and 75, the distance travelled between 5 and 10 seconds is, I believe, 125 meters. So the distance travelled between 0 and 10 meters would be this area plus this area of the graph. So as it says here, 50 plus 50 plus 75, 50 is 50, 75, is 175 meters total travelled in this whole graph. And I believe there's an exam style question here. Explain why the area under part of a velocity time graph gives you the distance covered. I think I explained this already, but I'm just going to go into further detail with it. If you think about it, on a formula triangle, I'll just draw the line here. Okay, explain why the area under part of a velocity time graph gives you the distance covered. If we draw our formula triangle again with speed or velocity, which is equal to, let's say, a velocity of 10, and time, which is, let's say, again 10 seconds, the distance travelled is the area under it, because the time goes along here and velocity goes along here, and because to find distance you multiply velocity by time, and to find the area of a rectangle you do that times that, because velocity and time are the two sides of the rectangle that you'd find, multiplying these two together will give you the distance of 100 meters in this case. So if we just write, first of all that, second of all, in the equation to find distance from velocity and time, you multiply velocity and time together, and velocity and time are the axes of the graph in which you're finding the area of the space under the line, x-axis, time, multiplied by y-axis, axis, velocity, equals, that's how you spell equals, yeah, area, which is distance. So let's find out the marks. First mark for stating the equation, second mark for noting that you multiply velocity and time in the equation, and third one for stating the relation to the x-axis and y-axis equaling the distance and the area. So that would be our 3-mark answer. So that is velocity time graphs. The main thing to take away is the fact that distance travelled on a velocity time graph is the area under the line. Very important. If you're going to remember anything of this, remember this line. Okay, that's it for velocity time graphs. I'll see you in the next one. Goodbye.